Hi all, so today we are going to switch from arithmetic, series, and sequences and look at geometric. So far with arithmetic, we've been adding or subtracting a common number each time. Geometric is a little bit of a switch on that, and we're going to talk about how it's different and what we do. We want to be able to, first of all, use geometric sequences, figure out their terms, know their places, how many there are, etc., and then also to be able to find the geometric means. Similar to arithmetic means, we're going to find those missing numbers, but how we do that is a little different, okay? Here's some more important vocab for you. You need to know what a geometric sequence is. It is a sequence that you get by multiplying each term by something. So instead of adding 5 each time, now we're going to multiply by 5 each time. The common ratio, this time R, is what you are multiplying. So for example, with arithmetic, we were adding or subtracting. Now we're multiplying, okay? And the geometric mean is, again, the missing terms between any two non-consecutive terms, just like arithmetic means. Same idea, you're finding those missing pieces in the middle. Now, the one thing that I want to tell you is really different when we're talking about R. R can be positive or negative, and that doesn't affect up or down. What makes a sequence go up is if R is a number larger than 1. It goes down if you're multiplying by a fraction. So for example, if we're multiplying by a half, our series or sequence is going down. If we're multiplying by 2, it's going up and it's doubling each time. So kind of be aware of that as we're working with this. It's a little different that way, okay? Sometimes we're going to see these kind of questions, so we thought we'd throw this in here. Find the missing term in the geometric sequence, 825, 125. So first thing you need to do is figure out what is it multiplying by each time. So 8 times what is 20? Well, here's the thing. 8 doesn't go evenly into 20, does it? So we know we're dealing with some sort of fraction or decimal here. So simply take, 20 divided by 8 and see what you get. That is 2.5. Now, test that out, see if it's your R, multiply 20 by 2.5 and see if you get 50, which you do. So now we've got our R, we can simply multiply 125 by 2.5 and we have the next term in our sequence, which is 312.5. So letter D is our correct option here, okay? So we're finding the missing term. In order to do that, we have to figure out what we're multiplying by each time. In order to figure out what we're multiplying by each time, simply divide the second term by the first term. Now again, I always like to double check just to be sure. So I will take whatever I think my R is and I'll test it out on one of the other terms, see if I get the next one, just to be safe, okay? So find the next 4 terms of the geometric sequence, 324, 108, 36, 12. Here we're finding R, okay? We know it's getting smaller. So I'm going to divide 108 by 324 and see what I get. It's really important here that you do not round your decimals. So when I do this, I get 0.33333 repeating, okay? I cannot write 0.3. That is not the same thing. What it is 1/3. And this is very, very important, okay? You cannot use a rounded decimal because it will not give you the right terms. You have to use the fraction. I'm going to check this just as I like to do, and I'm going to multiply 1/3 by 108, and I do get 36. So I know this is the correct R here. Now to find the next 4 terms, I'm going to write out what I have so far. And then 1, 2, 3, 4. I'm just going to multiply 12 by 1/3. Remember, you have that lovely fraction button on your calculator that does this, and I get 4. I'm going to multiply 4 times 1/3, and I get 4/3. And I'm going to multiply 4/3 times 1/3, and I get 4/9, which I'm going to multiply by 1/3, and I get 4/27. I could keep going with this. I don't need to because I found my next 4 terms. So once you find your R, your multiplying ratio, whatever that may be, simply multiply it to get the next terms. There is a formula for this, okay? It's similar to the arithmetic one, but a little different. We've got a sub n is equal to a sub 1 times r to the power of n minus 1. So this looks a little bit different because we've got some exponents here, okay? And we're going to learn how to work with this. Find the 8th term of a geometric sequence for which the first term is -3 and the ratio is -2. So we want to find the 8th term. My first term is -3. My r is -2. And remember, my n is 8 because I'm finding the 8th term. Let's simplify. So we start in the exponent. 8 minus 1 is 7. So now we have -2 to the 7th power. Guys, when you put this in your calculator, it is very, 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 very important that you use parentheses, okay? So I'm going to take -2 to the power of 7. In my calculator, I have this little button here, and that takes an exponent, and I get -128. Now I can multiply that by -3 and find out that my 8th term is positive 384. So there's some evaluating involved here. You got to be really careful to follow your order of operations, to be careful of your signs, and make sure that you're putting it into your calculator the right way. Parentheses are important, guys. You need to use parentheses when you're doing this stuff, okay? We now want to be able to write an equation for the nth term. So we want to write that generic equation, and we know that our first term is 3. I'm going to put that in for A1. I don't know what my R is yet, but I can figure it out, right? Because what am I doing? I'm multiplying by 4. I'm multiplying by 4. I'm multiplying by 4, which means that my R is 4. There is my formula for this specific sequence. Now down here, I'm told I need to find the 20th term. So I'm just going to put 20 in for n, and I'm going to see what I get. 20 minus 1 is 19, so I'm going to take 4 to the 19th power. I think we're probably going to get a really big number here, but let's try it. Yeah, 4 to the power of 19 is 2.7 times 10 to the 11th power. I'm going to leave that on my calculator, and I'm going to hit times 3. And I'm going to get that the 20th term is 8.2. I'm rounding, and that's okay, times 10 to the 11th power. And I'm just going to leave it like this, okay? Most of the time, we're probably not going to ask you for one that's super gigantic like this. Just kind of helpful to know how to put all of it in. So we put in 20 for n. We evaluated our exponent first. Then we multiplied by 3, and we got our number. Now we want to find the 10th term of a sequence for which A4 is 108 and R is in 3. So this is a little tricksy because we know the 4th term, but not the first term. Could we figure out the first term? Because that's what we need for our formula, right? We want to find the 10th term, but we need to know the first term. We know R is 3. Could I use that with my 4th term and go backwards maybe? If I know that 108 is the 4th term, couldn't I divide by 3 to go back to that first term? So for example, 108 divided by 3 is 36. 36 divided by 3 is 12. And 12 divided by 3 is 4. Now I know my first term, and I can put that in. And then I can go ahead and evaluate. So 3 to the 9th power, because 10 minus 1 is 9, is 19,683. And then I'm going to multiply that by 4. And I get a 10th term of 78,732. And there we go. So geometric sequences are very similar to arithmetic, except that we are multiplying instead. And the formula, again, looks a little different, okay? we still want to be able to find missing numbers. So if I have 2.25 and I have 3 geometric means between that and 576, I need to figure out what my R is so that I can then multiply to get those missing terms. So let's put what we know into the formula. 576 is AN, and that is the 1, 2, 3, 4, 5th term. My first term is 2.25. R, I don't know, but I know N is 5. So let's evaluate. 576, 2.25 times R to the 4th power. I'm going to take 576 divided by 2.25, which is 256. So what to the 4th power is 256? How do we figure that out? On your calculator, above that little caret button, you should see something that looks like this, okay? You are going to hit your index, which is 4. You know what? Let's try this a different way. Let's take 256 to the 1/4 power, okay? So on your calculator, do 256 to the power of, and then do 1 ABC 4. And you should get 4, which means that your R is 4. So we can multiply each term, 2.25 times 4 and get 9. 9 times 4 and get 36. 36 times 4 and get 144. And then just to check, I'm going to multiply that by 4. And I do, in fact, get 576. So I found my missing terms there, which are my geometric means. Hopefully this is making sense for you with the geometric sequences and then finding the missing pieces so that you can work with these things, okay? As always, this has been brought to you by Khan Alonso Inc. We hope that you are enjoying learning about sequences and series.